Hello and welcome to session 3 on string functions. Before we get into the discussion of the functions we're covering today, we're going to just revisit memcpy just to understand what goes on behind the scenes in memory. We're going to go back now to the program that we executed in the last session and just execute the program itself. And you would recall that the output was something like this, with that last part being from the source. But what exactly is going on in memory? Let's understand that through a slide. And what we have here is just 3 lines of code from the same program, right? And the arrangement in memory would be something like this. We know that destination is before source from the code we wrote. So in effect, source would start here and destination would start there. And of course, there's a difference of 5 bytes between source and destination. So what happens when memcpy executes? Of course, these 5, including the space, would move here, and then everything would move forward, leaving us with an output like this, right? And so you can see now that the last 5 characters are the remnant of source itself, right? And of course, that's because we do not have enough space in destination. If we increase the space, right, then we would get the right output. Now about size t, why have I introduced that? We'll come to that shortly. Let's just go now and discuss the next function, which is mem move. And you will see from the prototype, this function returns a pointer to what we will see shortly. Takes as argument a pointer to the destination and a pointer to the source, as well as size t type count. Note that the source has got the keyword const applied to it because the source is not going to change or be modified. It's the destination that is going to be modified. This function copies count bytes from the buffer pointed to by source to the buffer pointed to by destination and returns a pointer to the destination. If source and destination overlap, what this means is that source and destination are within the same string or the same buffer. Then the contents will be placed correctly and destination is modified. So now what we're going to do is we're going to go back to code blocks and we'll use mem move now. And let's keep enough space in destination. Let's see the results. Right, so this is with 2 different buffers. As you can see, we've got destination and source separately. We'll look at overlapping after this, but you can see we get the same result as memcpy, right? If we reduce the amount of space in the buffer and if we run this, again, we get the same results that memcpy gave us. Now there's one thing to observe here. If I go back to using memcpy and I don't use count, but instead I use strlen of source and I run this now, you will see that memcpy gives me the same result as earlier. That is when I used count, right? If I use mem move though, you can see that it's kind of messed up in terms of the output, right? And therefore, if you use count here instead of strlen, then you will get the same result as memcpy, right? So that's one observation. Most important to note with both these functions is to ensure that you have enough space in destination. Now coming to overlapping. You can see we have one string here and we just have that pointer which is initialized to S2. We're printing the string as it is, printing the pointer as well. That should print the same string, right? And then we are using here not str and cpy, but we'll use memcpy first right? And then we'll use mem move and compare the results. So if I run this now, so that's memcpy. You can see my destination was first plus 7, right? So first is initialized to S2, that's starting from 0, 0, 1, 2, 3, 4, 5, 6, right? So it'll start on O. The source is first plus 22. So if you count those, it would be just on O, right? And therefore it's given us this result. What about mem move? So if I use mem move now and observe the results, you will see they're the same, right? So memcpy and mem move giving us the same results. But having said that, it is recommended both by GCC, right? That's the compiler we are using, as well as Linux for that matter, that we use mem move when we have source and destination, tending to overlap or may overlap, right? So unless you're absolutely sure there's not going to be overlapping, you need to use mem move. Okay, so moving on now. We need to understand how memcpy is defined in the standard library versus how memmove is defined in the standard library, right? Just to understand the difference in how they work. So we have buffer 1, 9 bytes, and we know memcpy takes 3 arguments, source, destination, and count. And you could have source and destination in the manner as displayed on screen. memcpy just uses one kind of copy, that's the forward copy. Okay, so star destination plus plus equal to star source plus plus. And the copy happens as the pointers move forward, right? How does memmove work? We know memmove also has got 3 arguments, but memmove evaluates. So if source is greater than destination, which could be something like this, where you have source there and destination before it, then memmove uses this formula, if you like, for this instruction. Otherwise, if source is less than destination, which means you could have something like that, where now we have source before destination, then memmove will recalculate or recompute the source and destination. How? By adding the value of count, right? So we have a new source and a new destination, right? Count is added, by the way, to both source and destination, and then it uses this instruction. So it does a reverse copy, right? That's how memmove works. And therefore, you may say that memmove is a little slower than memcpy, but as I mentioned, if there is ever any chance of overlapping, it's important to use memmove and memmove alone. Now what we're going to do is we're going to write some code and write our own version of memmove for a situation where source and destination are within the same buffer. So we're going to go to code blocks now and we start a new file. And we start with hashtag include stdio.h and hashtag include stdlib.h and then hashtag include string.h. Now we need to declare the function that we're going to define later. So char star my mem move, and the parameters will be char star buff1, char star buff2, and size t type count. And here we can have now our main function, and we'll have here 2 pointers, right? But before that, we'll define the string or the buffer. So buffer1 equal to, and I'm going to use the same string as we used when we executed memmove. So we can compare the results of the mem move we are writing to the results of the actual mem move. And then our pointers, as I mentioned, that will be from equal to buffer1 plus 22, and then char star2 equal to buffer1 plus 7. And then we can call our function passing in the arguments which are from, or rather to the destination first, then from, and the number 12. Printf the output. So %s \n comma buffer1, and of course then exit the program, so exit 0. Right, now we can write our function. So char star my mem move, and pass in the parameters char star buff1 comma char star buff2 comma size t count. And here we'll have 2 pointers, char star destination equal to buff1, and then char star source equal to buff2. Remember, buff1, right, corresponds to 2, which is our destination, and buff2 corresponds to from, which is our source. And now we check if source is less than destination, which means source is before destination. Then we say for, and we're going to compute a new source. So src plus equal to count, and we're going to compute a new destination as well. So destination plus equal to count. The loop will run as long as count is not equal to 0, and count will be decremented by 1 every time the loop is executed. Within the loop, just one instruction, star minus minus dest equal to star minus minus source. Else, so that's if source is not before destination, which means it's after destination, then you can use either a while loop or you can use a for loop. For, no initialization there, the loop will run as long as count is not equal to 0 and count minus minus, right? So count will decrease by 1 every time the loop is executed. The instruction here will be star destination plus plus equal to star source plus plus. And then we need to return buff1 and buff2, right? Let's run this program. Okay, the semicolon missing there. And you can see we get the same result, right, as we got with memcpy and mem move. So our mem move is giving us the same result. Now moving on. strncpy is very similar to strcpy. You can see from the prototype this function returning a character pointer and taking as arguments a pointer to str1, which will be the destination. There's a pointer to str2, which will be the source, and then we have size t count. Copies up to count characters from the string pointed to by str2 into the string pointed to by str1. str2 must be a pointer to a null terminated string, just as we saw when we worked with strcpy. Right? Remember why str2 must be a pointer to a null terminated string? Because if str1 is going to be overwritten, then str1 itself needs to be terminated. Returns a pointer to str1. Now what we'll do is we'll go back to code blocks and we'll use strncpy now. Right? Let's run this and see the results. Okay, it's a spelling mistake there. Right, so you can see this gives us the results we would expect because we have enough space in our buffer as well. If we do not have enough space in the buffer, then what does strncpy do? And you can see it gives us the same results as we had with memcpy and memmove. Right, so bottom line is that you need to provide enough space in the buffer. What about if source and destination are within the same string? So let's try using strncpy here. And again, it gives us the same results as memcpy and memmove. But as I said earlier, when source and destination are within the same region or the same buffer or the same string, then it is important to remember to only use memmove and no other function. Right? Moving on. Memset. You can see from the prototype, this function returns a pointer and takes as arguments $buff, pointer again, and int ch as well as size t-type count. Returns a pointer to buff, right? Copies low order byte of ch. Remember, ch is an integer, so the character would be found in the low order byte. It copies that character into the first count characters of the array pointed to by buff. It's used to initialize a region of memory to some known value. So now what I'm going to do is I'm going to take you back to code blocks and show you a demonstration of how this works. That is memset. So just a short program, we have a hash define, right? And we have size there, and that's 70 bytes. And we're using that size to size our array or our buffer. We have a pointer. That pointer is going to be used to trap the return value of memset. Remember, memset, as we saw on the slide, returns a pointer to buffer1 in this case. Then we have the character that we want to put into 70 bytes. Right? Size represents 70. Then we're using memset again, passing in buffer1, characters x this time. Number of bytes is 30. Printing out buffer1 and both pointers, or rather both addresses, ptr as well as buffer1. Right, so now let's run this. And you can see we have those 30 x's. So you may see in some documentation the return value of memset being the value of buff, which is valid. It's also valid to say that it returns a pointer to buff, right? Both are valid. Right, so this ends our session for today. In the next session, we look at more string functions. Till then, take care, stay safe. Bye.